Welcome to the OpenDS webinar of July 2014. This month we are going to discuss how to add dynamic triggers to OpenDS, for example when they are attached to autonomously moving traffic vehicles, and how to interact. So for example, a user of our OpenDS community raised the question, how can I make the OpenDS report the distance from my car to another car? For example, if the distance gets too close, how can I raise an event? In this webinar, we're going to face this question and find a solution. So first of all, I'm going to show you the requirements for this webinar. You should have at least basic knowledge of OpenDS. That means it would be good if you had worked through the tutorials of last year's OpenDS user convention, which contains in the tutorial 1 details about how to edit driving tasks, especially trigger actions, and working on the interaction XML would be quite important. Furthermore, you should know how to set up computer-controlled vehicles, which is done in the scenario XML file. You can ask us for the materials of that tutorial. We can provide you with slides and basic code samples to fulfill a tutorial. Furthermore, there's a recording available on YouTube where we go through the tutorial step by step. So these are the user requirements. However, as we are working on the source codes in this webinar, you would have to meet further implemented requirements. These are the following. You should have at least basic Java skills. You should know how to set up OpenDS in your IDE. In my example, I will do it in Eclipse. You should know how to create simple objects. This is something we already discussed in tutorial 2 of the OpenDS user convention. We also have the materials available for that, and again a recording on YouTube, as you can follow the link at the bottom of that slide. Unfortunately, the recording is not complete, so the second half is missing due to technical reasons. However, in the tutorial, we give an introduction how to create boxes, spheres, cylinders, and other very basic objects that are provided by the JMonkey engine. Furthermore, you should know more about the basic concepts of the scene graph, which is about spatial representation, spatials consisting of nodes and geometries, for the representation of scene graph in the tree representation. You should know a little bit about materials and the notion of culling, making objects visible or invisible. This is the object where we are going to start from. This is the end point of tutorial 1 from the user convention. When we went through the tutorial, at the end we reached this step. We created a city environment, we added vehicles, we added road signs, and these colored boxes are the triggers we added. This is our basic starting point for today's webinar. You can download this model in that status from OpenDS EU download section. You will find it, it's called somehow like Materials of the First Webinar, from a former webinar where we already referred to the tutorial model. So again, here's the problem. which reads how to trigger an event if the user-controlled car is getting close to a computer-controlled vehicle. So let's first split this problem into smaller steps. So first of all, how can we find out our current distance to a traffic vehicle? So what would be simplest is to place a bounding box around each vehicle, and on contact with this bounding box we will report a collision. So depending on the size of this bounding box, we know the distance when the alert is first raised. So ideally, we would replace a bounding box by a bounding sphere to be able to measure the distance in each direction in a similar way. So the first idea would be to add a bounding sphere around each and every computer-controlled traffic vehicle. However, we should not be able to collide with that object, as otherwise it would lead to a crash and would have any impact on the driving behavior. So thus, this bounding sphere may not be collidable and not visible as well, as we don't want to see boxes moving through our model. Furthermore, which is the second point, we need to attach these moving spheres to the computer-controlled vehicles, as the center of the bounding sphere has always to be the center of the moving vehicle. Furthermore, to address these bounding boxes, these bounding spheres as triggers, they need to be assigned by unique IDs. So what we could do in here is, as all the cars have already unique IDs, we could reuse the same ID plus some suffix, for example, bounding sphere, which we will see in the next steps. Furthermore, we have to add each sphere to the trigger node, which is responsible for checking of collisions with my own driving car. And after that, when I'm able to detect collisions with bounding spheres, I can assign events. So, for example, I can output a message to the screen whenever I hit the bounding sphere, which means I came too close to one of the driving vehicles. Knowing the ID, I would also know the ID of the car which I approached too close and can output special messages according to that ID. So let's dive into the first step, where we want to create suited objects without physical properties, as we already said, a sphere. As you see here, this is already a concept that's available in the JMonkey engine. It takes 3 parameters, 20, and the second 20 describes the sample rate for the visualization of the sphere, whereas the third parameter is the radius. So in our example, we are using a radius of 2.5 meters. So the second step, we attach this sphere that we have already created to the car. So this is done in the last line that you can see here. And we provide a unique ID, which you can see here. To have something that we could add to our scene graph, we need to have a geometry or a node. So as this is our leaf and there's nothing beyond this bounding sphere, we decide to have the bounding sphere as geometry. We create a new geometry and we add a name here. The name comes already from the car, and we add underscore bounding sphere, as already said. Furthermore, we hand over that sphere to that constructor of geometry, and we get a bounding sphere here. And this is what we add to our car node. So what we have here is the generation of sphere that we attach to the car node. That's why we have to place this code to the position where the cars are generated to the constructor of the traffic cars. So we are moving over to the third step, which is the collision check. So as already mentioned, only those objects that are attached to the trigger node will be checked for collisions. So what we do next is we just take the car node, which contains a bounding sphere, which again contains the graphical representation of that sphere, and take all of them and attach them to the trigger node. So then we already have almost everything. These are just some additional properties that are required for the description of the material. So first of all, we have to create a new material that is unshaded, and we using this method setColor to set the color property to yellow. After we have created a yellow material, we just set the material to this one. The line you could see here, which is commented out, will make the sphere invisible. But for debugging purposes and for the visualization during this webinar, we will keep it in that way so that you can see later on the bounding boxes moving amongst the car. So then we are almost through. This is the final code we have to add to the constructor of each traffic car. This will generate a yellow sphere with a radius of 2.5 meters, and this sphere is attached to the car node. It will move with the car all the time, and it will be included to the trigger check. So what we would do at this point, we try it out and have a look what happens when we add this code to OpenDS. So first of all, I start OpenDS as I have added it to my IDE. Just start it in the usual way to show you the model. Tutorial. And you will see the model from the tutorial of the user convention. We added nothing. You just see there's an empty model. We have cars moving here. We have these bounding boxes, these trigger nodes, and a car moving by. So you see there's nothing spectacular in this model. So we'll close it again, and we will go to the traffic car class. As you have OpenDS in your IDE, you can browse through the packages. You can go down to traffic, where you will find the traffic car. So I just prepared this piece of code. I just have to comment in, and what you see here is again the same code as we prepared in steps 1 to 3. First we add a sphere. For this sphere we create a geometry. We use the name of the car that has been added just before. Add underscore bounding sphere to have an unique identifier. Pass the visual sphere for generation of the geometry. After we add the yellow material, we add the bounding sphere to our car node, and again the car node will be added to the trigger node. So let's have a look at what happened here. Again, we load the model of the tutorial. And now you see there's a yellow sphere wrapped around the car. We cannot even see the car anymore. But as you might have noticed, there was nothing happening when we collided with this yellow sphere. So this yellow sphere was going through our own car. Can have a look from the outside. We have also a yellow sphere around us, and there's no contact. We close it again and go on. Here you see again what we did so far. Without modification, we had traffic cars moving along the predefined tracks, and on the right you see we have the same traffic car now with a sphere wrapped around it. So let me now explain you a little bit more what we did in words of the scene node. First of all, the main node of the scene graph is called the scene node. It contains all the descendants which will be visualized, which will be rendered. So this is marked blue here. All the subnodes of the scene node will be shown on the screen, will be rendered. The trigger node, which is also a subnode of the scene node, will be this exclusive node that checks for collision with the driving car. So every subnode of the trigger node will be checked whether there's a collision with my car. Currently, this trigger node is empty. What we did now is we attached these spheres to all the driving cars, to all the traffic cars. So this looks as follows. So in my example, it's just 2 cars, but we added a bounding sphere to each of the driving cars. So as the bounding sphere is also a descendant of the scene node, it will be rendered. It's contained in this blue box. It will not be checked for collisions as it's not contained in the trigger node. But what we did is we moved the car node to the trigger node. We did the following. Now the cars are still contained in the scene node. That means the car is still visible and they will be rendered. However, now the cars, including the bounding spheres, are contained in the trigger node, which means they will be checked for collision. So this is quite vital to have the task fulfilled. However, there is still a small problem with the current implementation, as the collision check only includes the immediate children of the trigger node. So not all the descendants will be checked for collision, but only the immediate children. So this is the car node, but not the bounding sphere. So what we would have to do now is a small adjustment to the existing code where we slightly change that behavior. And this could be done in the trigger center. So you will have to go to your OpenDS implementation, to package EU OpenDS trigger. There's a class called Trigger Center where you will find the following. So it's around line 90, where there you will find the following. We ask the trigger node for all list of his children in the current state. However, we don't want to only have the children, as we want to have all descendants. We have to replace this by our own implementation, where we use the method getAllSpatials. This method will query all the descendants of the trigger node and will return a list of spatials as it was done before by only the children. So what we would have to do next is to go to the trigger center, which can be found in package trigger, go down to the trigger center, and I already prepared this code here. I just comment out the old version and uncomment the new version, where we have a new implementation for the request. However, as you see, this method is not available yet. What we will have to do is to add this. I have prepared on the next slide how this will look like, and we just copy and paste the whole method, which walks through the whole tree, the whole subtree, and returns a list of all the content spatials. So we go to the package EU OpenDS tools util, where we create the new method getAllSpatials. So let's do that. We go back to the implementation. There's the package tools. We have the class util. So I already prepared. You can add it to any part of the util class. So it's totally up to you. I just uncomment this part, and it's exactly the same code I represented you before in the webinar slides. These slides, of course, will also be available apart from the recording. So now let's store this, and you see in the trigger center the method is available. Going back to the slides, let's see what we did now. We fulfilled the first 3 steps of our problem. We created a sphere, we attached this sphere to the car, and we set our trigger collision checker to check whether our driving car, our user-controlled car, is in touch with any of these yellow bounding spheres. What we have to do now is just to assign events in case of the driving car has hit any of the yellow triggers. And this is what we do here. We don't need access to the source code for this. This is something that could be done in the driving task files, especially in the interaction XML file. We would just have to add this regular XML code in order to add send message to the action whenever a certain box or sphere has been hit. So let's do this, and we go through the details in a minute. So first we go back to our implementation. Now we leave the source code and we go to the assets folder, which is attached to all OpenDS instances. We go to the driving tasks, where we have the projects folder, and currently we're working on the tutorial folder. There we find an interaction XML. So we go here. This is just some artifacts from what we did last time in tutorial 1 from the OpenDS user convention. And this is the part I showed you on the slides. I'm just going to comment in now. What we do here is we just add a new trigger. We call it as you like. In that case, I want to find out whenever I get too close to car 1. So I just named it too close to car 1. Each trigger consists of an activity, at least one activity, and a condition. The condition is a collide with condition, and here I specify the ID of the object I want to check for collision. I could also just write here car 1, then I would check for collisions with car 1, which means I would have to collide with that car. However, I just write here car 1 underscore bounding sphere, which means I would have to collide with the bounding sphere of the car, which means I'm still 2.5 meters away from that car. So whenever I'm getting too close to that car and I'm only 2.5 meters ahead of that car, the following activities, in our case it's just one activity, will be triggered. You can again provide an ID, which is not needed. I called it show warning text, and it has the action with the keyword send message. You can add delay or a maximum restriction, how often it could be repeated. But I set both to 0, and there are 2 parameters you have to pass. One is text, one is duration. You have to specify the message that will be shown on the screen. I just named it too close to car 1, and the duration in seconds, which I set to 3. So when we now hit the car 1 bounding sphere, a message will pop up showing too close to car 1, and this message will last for 3 seconds. So we save these changes and start the simulator again with the tutorial task, and then we will see what happens. By the way, if you find the cars moving very slowly, it's not just because of the low frame rate, it's because of the recording. The refresh rate for the recording is maybe low. Now we're in here. This is not car 1, so you will notice there is nothing that happens. As this was another car, I can tell you car 1 is expected to come now. Yes, the next yellow sphere is car 1. And you see, only when we hit the bounding sphere of car 1, the message will be shown, as it is here. Okay, so there's only one thing left to do. We have to go back to the traffic car, where we have to uncomment the visibility of the bounding sphere. So by setting cull hint to always, we make the yellow bounding sphere invisible. It will still be there, but it will not be recognizable by our driving car. So if we now go back to our model, we will again see a car, the red one, which is not car 1. And therefore nothing should happen. So the red one will pass by, nothing will happen. We will just have to wait a minute. Then the green car, which is car 1, will drive by. And as soon as we are closer than 2.5 meters to this green car, the message will be shown. Okay. Of course, you not just can only send messages to a screen. You could also use this to raise any other trigger actions. For example, you could implement your own trigger action which sends information to the server application, or you could perform other options as well. Finally, we reached the end of this webinar. I hope you enjoyed it. We will provide all the materials in our download section, and we would be happy to see you next time. Goodbye.